Hi, Carl Ford with M2M Evolution here in Santa Clara at Sprint's Open Solutions Conference, and I'm here with Mike McKinley. Mike, thank you for being with me. You're the Director of Engineering at GridSentry. We've got a nice logo here that people can follow, and we have a somewhat gigantic prop. So congratulations, you are the biggest M2M implementation we have to display here, of course, other than the ambulance. Okay. We'll ignore the ambulance. But what's really neat here is this is a device that, well, let me have you tell people what it does. So what does it do?
This M2M device actually goes on the power line, helps utilities optimize their grid by giving them information real time. Gives them that information so that they can find out where the outages are, so they can help them optimize the amount of energy that gets from the production to the users.
And I see here that we have a spot for the radio to go in, we have a spot for the sensor, we have basically a spot for it to get its own power from the power line.
Yep.
And to siphon off the power line, so that's pretty cool. Just out of curiosity, normal implementation, people keep telling me that the smart grid's pretty much already enabled. Are we finding that it's still pretty much a dumb network and you have lots of customers asking you to help them kind of get a better feeling as to how they're dealing with the transportation of the energy back and forth?
Well, primarily what people think of when they think of smart grid, they think of smart meters, the idea that they put meters on the home. Well, that is good and that does help. The idea of that is to help the users make decisions that are better to use less energy. What this does is it helps them find where the losses are and to quantify them. They are still basically dumb wires in between. So the idea is to make those smart enough that when they could go out and make studies, they can do it real time, and then now they can optimize their system.
So we've got the power source, we've got the transport function, we've got the distribution function. Do I only see this on the transport side and by the artificial islands, or is this in distribution areas as well?
This is primarily for distribution from the substation to the last pole.
Okay. Okay. And so typically we've got, like, for the substation, how many have we got out of these things? Are we putting one out on every part of the grid, or is it something that we put out in a kind of a sampling mode? How do people use it?
The primary plan from the utility's point of view is every 4 to 5 miles they'll put one on every phase. That way they can break up the grid small enough that if they do have an outage, they can say it's between here and here, and by looking at the data they can get even better idea. Right.
Now the thing that always impresses me is that the utility companies always seem to have massive disasters. Okay, I mean,
yes.
I'm from New Jersey, and right now in New Jersey we have this interesting thing going on where the storm came and wiped out, basically 2 million people in New Jersey without power for a while. And is this system make it so that they've got more information quicker about how to solve things, or is it major disasters are major disasters and it's not going to change much on their prioritization?
Well, what this can do is help utilities make the decisions as things are happening so they can try to prevent outages that are going to happen. As they see problems starting to happen, they can say, okay, we got to do switch here or here. They can also say, oh, this did happen. This is what happened that caused it, and this is where it happened, and they can get it back on quicker.
So now I just locked this thing up, and you've got an LED here that you don't necessarily use. We talked about the fact that this is the side up. Now, typically, what's the relationship with Sprint? How does Sprint play a role here? The radio is I assume CDMA?
CDMA.
Okay.
We consider ourselves communication agnostic. We'll use whatever the utility wants, but being that we have Sprint as a communication partner, what we're doing now is promoting and going out and releasing the CDMA so that we can get Sprint's help with customer partners.
Okay. And any places, am I going to see this in New Jersey anytime soon? Or
actually, they have been up in New Jersey. They actually went through the hurricane, and they were giving outage information then, and actually most of them survived through that outage time.
Okay, and I don't know which company you're working with in Jersey, but one of the companies has put out a lot of solar panels too. What's the role of renewables in this thing as people become more two-way and people bring their electronic vehicles with battery functionality and put up solar panels and other renewables? Do you have an expectation that you're going to have to give two-way information for people?
This does have two-way information built into it so that you can control the endpoints and set points for like where you want fault information. It also has the ability to control the time you get things back, you know, how long between samples. But yes, I think it'll play a very big part as we go into adding on electrical vehicles where they already know they're going to have problems with having overloads and overheating and pushing the grid even more. With the line temperature, they can push more through and know what the limits are without having just using rules of thumb.
Cool. Michael, thank you so much for your time. I really appreciate it.
Thank you very much.